so it's only a class of like 4 now. Okay, degrees to radians. Let's do another practice one. Find what 120 is in radians. So convert 120 degrees to radians. So it has pi in it. Yeah. Did you write it down yesterday? Oh. Okay, well, it's that in blue on the board. Okay, so 330. 330 degrees. Change it into radians. And radians should have pi in it. It's chapter 7. Is it on?
I didn't see it on that.
It might be in the folder. Yes.
Like, if I know how to run a computer, I don't know how you buy it.
Yeah. I would definitely look. That's pi. Yep. I would definitely look back at the video and watch it. Okay. Okay. So I'm multiplying this by what? Pi over 180. So if I want it in terms of pi, what do I have to do? Yep. So I'm just taking my degrees. Oops. Dividing it by 180 degrees. And I still have my pi because I don't want to multiply by it, so I'm keeping pi in there. So what is 330 divided by 180? Give me it as a fraction. Okay, 11 over 6. Great, that's in radians. Now let's switch it back. So I'm doing the same thing now, but I start with my radians. What's up, Mark? Do you have a question? No? Okay. So if I have my radians, let's call it always going to be as a fraction. So my radians times, we're going to flip our clever choice of 1. So it's 180 degrees in my numerator. And my denominator is now pi. And this is whatever my radians is over here. Let's denote it just as radians. So let's go backwards. We had 11 pi divided by 7, right? That's in radians. Okay, how do I convert it back into my degrees? What do I multiply it by? Okay, 180 degrees divided by pi. Can I simplify this right now? Yep, what can I get rid of? Yep, get rid of pi. Okay, I'm going to say this one more time. This is pi. What was it down below? Well, we're going to make it 11 pi divided by 7. We're changing it. Okay. Okay, we are getting rid of pi. So what am I left with? 11 divided by 7. times 180. So keep that fraction. Just get rid of pi. What does that equal? Okay, I want everyone to get a calculator and calculate it. You can do a decimal for this one. What is the decimal? 2.85? Okay, I was going to say. 285 what? Okay, 282. What? 857. Okay, I think we're good with the decimals. Well, what's my label? Degrees. Yep. Do you want to do another one? Yeah. Okay, one more. Lily, give me any radians you want. Okay, that is a fraction, and I like it. I need to add pi, numerator. Yep. Okay, Lily picked a big one here. 15 pi divided by 6. Change it into degrees. This radian as degrees would be what? So Landon, what do I have to do? Mm-hmm. Okay, go ahead, try it out. So she got 450 degrees. Okay, which one do we like better, radians or degrees? Radians, thumbs up. Degrees, thumbs down. Want to go back to logs? Okay. We're going to focus on 3 main radians. So I was sticking with radians for a second. Then we'll go to degrees. Do you want to sketch? Should we sketch? Let's sketch. Yes, we're going to do the circle in a minute. So I want you to convert pi 6, pi fourths, and pi thirds all into degrees. Convert into degrees. Not just 180.
Does it matter what we
Well, yeah. We had to do a clever choice of 1, so it's not just 180. We also have pi in there. Yeah?
Yeah, I got that from these ones because
Mhm.
you just find the 180 they cross out.
Mhm.
When we're here, I know that we need pi, but we can't just use 180.
No, because you have to remember all of it. That it's 180 over pi.
Yeah.
Yep. And then we get to cross out the pi's. But you have to include that first. Okay, talk to the person next to you. See if you got the same answer for all 3.
Is it like this?
Yeah.
Oh. So it'll be crossed out. It'll be 6. Yeah, I see very much.
Okay, if you're done, I want you to sketch this. I want you to sketch the radians. Yeah. So prior to this, we're multiplying the numerator and the denominator parts, right? So if you got rid of these, these would be ones, right? Yeah.
45.
Oh, that's fine.
Pi with something. Yeah.
Is it on one?
Yeah.
Kind of graph.
Well, what are you doing?
I'm just gonna. But, no, not fucking.
I don't have a table.
But no, yes. Whatever.
Okay, like so we can see.
Yeah. That's why it's really confusing.
So which one is the
I don't put you at all. I'm just here. But at least, yeah, at least you get that spot because you're that good. I mean, there's no, there's just no. I mean, knowing you have competition, but you have good for being good, but just not having gears yourself.
Sketch all of them? Okay, that's because you were here. So. Maybe 15.
Can we do it on a calculator?
Sketch them?
Yeah.
No, we can't do it on calculators.
Even if we put it on a table?
Yeah, no. We can't sketch them. Okay, what did we get for degrees for pi 6? 30 degrees. What about 45? Yep. What about the next one? Yeah, because that's just, my mind automatically goes there. Okay, so if we sketch these, we should have gotten something like so. So this is about 30 degrees. And then the next one up is about 45 degrees. And then we go up one more. About 60 degrees. If you did these separately, that is okay. Yeah. So that's the start of what we're looking at. This is, what quadrant are we in right now? 1. We are currently in quadrant 1 of the unit circle. So we have 30, 45, and 60. Now these are in our radians. If I go a full circle, how many radians am I going? Okay, that is in degrees. 2 pi. Yep. Do we know how? Okay, I want you to convert 360 degrees into radians. Yep, but I want you to show the work, because not everyone gets that. 360 degrees is the entire circle. So the entire circumference is 2 pi. Yeah. Okay. So 360s in degrees. This would equal to 2 pi when we're talking about radians. Okay, we're going to count these radians up. You don't have to convert it into radians. We just talked about it. So if you did this, 360, and we times this by pi over 180 degrees. So what is 360 divided by 180? Yep, 2. And then we just keep our pi. Yep. Okay. Okay, we have to get all the way up to 2 pi. We're going to go with 30 degrees. Okay, we're chopping our unit circle up into a whole bunch of 30 degrees. Okay? Yeah? Okay. So let's keep going. I have to get all the way up to 2 pi. If I had that as a denominator of 6, how would I write that? Yep, 12 pi divided by 6. Okay, so 12 pi divided by 6. So what is in between here? I have to add 1/6 each time. Yeah? Yep, because I'm going up by 30 degrees. So it's like 60 degrees. Then we have 90 degrees. So going up by 30 each time. Oh, by 30 degrees each time, which is pi 6. So I do pi 6 plus pi 6. What do I have? 2 pi 6. Yeah? Okay. What does that simplify down to? 1/3. Isn't that the same as down here? 60 degrees? Yep. Okay. Keep going. What's next? Louder, guys. Okay. Yep. 3 pi 6. What's next? Mm-hmm. Keep going. Keep going. Okay. 7 pi 6. Yep. Okay. Someone from the other side of the room now. 9 pi 6. Yep. We're going up by pi 6 each time. So adding 1 to the numerator. Keep going. Landon, what's next? Mm-hmm. Okay. I'm running out of room. What's next? Yep. Last one? And why is that my last one? Yep, it simplifies down to 2 pi. Okay, which other ones can I simplify down? Okay, yep, 6 pi 6 is what? Pi. Okay, what else can I simplify down? Okay, what did that simplify down to? Pi over 2, yep. Yep, what does that simplify down to? 2 pi thirds. Yep, we're just simplifying down fractions. So, Sunny, we have 2 pi over 6. So 2 and 6?
1 pi 3.
Yep, pi thirds. Okay, this is even over here. 8. Yep, 4 pi thirds. What about this one right here?
5.
Yep, 5 pi thirds. Okay. Hey. What? Yeah, what would that simplify down to?
3 pi.
Yep, 3 pi halves. Okay, we're just simplifying those down. What is in most of these denominators? Okay, 6 is up there. So we have this one we kept, this one we kept, and this one we kept. And our original. There's a 3 in the bottom of these. What is pi thirds as a degrees? You have it all on your paper. Yep, 60. So this was 60 degrees. This was 120 degrees. We're going up by 30 each time. And by going up by 30 each time, I'm going to hit 60 degrees, right? I'm going to hit 120 degrees. Okay, so let's go up by 60 degrees. Guess what? They're already up there. So what's next? I'm going up by a third each time. Yep, 2 pi thirds. What's next? 3 pi thirds. Yep, what's next? Mm-hmm. Kennedy, what's next? Yep. Liam, what's next? Mm-hmm. And can I keep going? Should I keep going? No. Why not, Angel? Yep. So this simplifies to 2 pi. Kyle, do you know any other ones that can be simplified down? Yeah. You got it, Kyle. What can I simplify this down to? Pi. Okay. We just broke up the unit circle a lot. Let's write this down on sheets of paper. On here. We're going to write down and start looking on the unit circle. So anyone pass these out, please? I just passed them. Thank you. You hit the other half. What? What do you mean by a point? There's one extra foot. Thank you. The 14th. Where's the point? Yes, we're going to put points there later. We can talk about it today if you want. Okay. Do you want to do degrees or radians first? Yep. Okay. This degrees right here is 30. We're going to go up by 30 degrees first. So we got 30. Where is 60? This one? Yep. This one is 60. So, what? It is 45. We're going to hold off with doing 45s, but yes, this one would be 45 degrees. Okay. If I make a 90-degree angle, which one should be next? Yep. What about down here? 180. Down below? 270. And what about here? Or, yep, it can be both. So 0 should be there or 360. Okay, so I'm going up by 30s. I went 30, 60, 90. What's next? 120. Okay, we're skipping one. Next one. 150. And if I go another 30, it's 180. We have that. What's next? 210. Okay, skip one. Next one. 240. Yes. And then I get 270. Great. Landon, what's next? Adding 30 each time. Yep, 300. Skip one. What's the last one? Yep, 330. Okay, we already did our radians. How many radians is 30 degrees? Look back at your notebook. Yes, pi over 6. What about 60 degrees? Yep, pi over 3. So there is our beginnings. Now, you guys all have it in front of you. I don't. We went up by pi 6 when we went all the way around and we simplified them. So we went up by 30 degrees. So what would be 90 degrees in radians? Yep, pi halves. Okay, going another 30 degrees. So no, going another pi 6. What's next? I go down here, I went pi 6 was 30 degrees, pi third was 60 degrees, pi halves was 90 degrees. Then our next one, yes, 2 pi thirds. What's my next one on my line? That I was going up by 30 degrees each time. What's next? Yep, 5 pi 6. Sorry, that's your guys' thing. So next 30 degrees should be 5 pi 6. So I'm going up by 30 degrees each time. So I'm going up by pi 6 each time. Yeah? Okay. So what would my next one be? Five pi 6 plus, yep. So it would be 6 pi 6, which we can simplify down to just pi. So we just have pi. Okay, going another 30 degrees. So going another, how much in radians? I'm going another 30 degrees, so I'm going another pi 6. So if I add a pi 6 to pi, what do we have? Yep, is the next one on your line in your paper? Yep, 7 pi 6. Natalia, if I went another 30 degrees, how much will my radians be? Yeah, 4 pi thirds. Which, if I wrote that with a denominator of 6, would be 8 pi 6. We're just simplifying it each time. Okay, another 30 degrees. Amy, what would it be? So I'm at 270 degrees. Yep, 9 pi 6. And can you simplify that down for me? That fraction. Yeah, 3 pi halves. So let's write the 3 pi halves, the simplified version. So we got 3 pi halves. Okay, going another 30 degrees. Sonny, what's this one in radians? Okay, 10 pi 6. What does that simplify down to?
5 pi
Mm-hmm. Okay, Kennedy, going second to last one. Going another pi 6. What would that be? I'm sorry, let me rewrite that. This is 5 pi thirds. Okay. I'm on this one. I'm going another pi 6. I'm almost at 2 pi. What would it be? Okay. So I'm at this one, 5 pi thirds, and I add another pi 6 to it. So where am I at? Yeah, 11 pi 6. So I'm at 11 pi 6. And what would my radians be up top? 2 pi, or also what if I started there? 0. Yes. Okay. We went up by 30 degrees each time. We still have spaces. And Landon told us our first space was how many degrees? 45. So we need to go up by 45 degrees. So, yes. So let's start with our radians. Okay. Pi fourths. If I add a pi fourths to that, what would the fraction be? Do we need a brain break? Yeah? Okay. Everyone up.
What we played yesterday? No, I didn't.
I don't know what we played yesterday. Yeah. Yep. Okay. First card. Black, red. Pick your side. Black or red? Black, red.
Always go with black. Always go with black.
Okay, ready? Oh, red wins. Black, sit down. Okay, red card. Okay, this one should be easy. Higher or lower? Higher or lower? The other one higher is an ace. Okay, ready? Lower. Okay, in between or outbound? Inbound or outbound? So in between these two or outside of these two? Outbound. Inbound. So a queen or anything else. Yep. Okay, ready? 10. So you guys lost.
You lost?
Yeah.
Oh! What?
Because it has to be in between. Okay, now suits. Diamonds, hearts, spade, clubs. Spades. Diamond, heart, spades, clubs. I always go spades or diamonds. Yeah, right? I think I shovel. Okay, ready? Good? Diamonds. Why are you in diamonds? Well, you are. Okay.
One more game.
Okay, everyone up. Everyone up. Okay, black, red. Yep. I mean, or we can go back to the unit circle. Really? Black, red. I just did. Okay. You're in red. You're in red. Okay. Black, red. What?
What's
again?
Okay, I cut the deck. Okay, ready?
Black.
Black.
I don't play this game ever again. I hate this game.
Okay. This is always black. That is always red. No, this is always black. This is always red. No, it's not. Okay. Higher or lower? Higher or lower? Higher? Lower. Okay, ready?
Lower, right?
Yes. Lower. Okay. Inbound, outbound. In between these two cards or outside of these two cards? So inbound, outbound. Okay, so you're in between these two. Okay, ready? Ace, outbound wins. Okay, now suits. Diamonds, hearts, spades, clubs. You can't see it.
It always wins.
Okay, ready?
Yes. What did I?
Clubs. Clubs. There you go. So this is a clubs. This is a spade. So this is a spade. Spade is a shovel. A club is a clover. Yeah.
It's so good.
What? Okay. Unit circle? That's what's next. That's what you said go to. Maybe at the end, if we get through the unit circle. This is just taking longer than I thought. Okay. We need to go up by how much each time? We gotta go up by 45 each time, which is how many radians? Yes, pi fourths. So we're just adding pi fourths to this fraction every single time. So what would be my next fraction? 2 pi over 4. So it's pi fourths, and I'm going to add a pi fourth each time, because I'm adding 45 degrees plus 45 degrees, which equals how many degrees? How many degrees would this be? 90 degrees, which is also equal to 2 pi. Yep. It's not 2 pi. Pi 2. Pi divided by 2. Yep. So this is pi 2, which Kennedy said was 90 degrees. Perfect. Okay. Adding another pi fourths. What do I get? Yep. Keep going, Landon. What's next? Yeah. Okay, what's next? Yep. Naomi, you're next. Finish it off. What's next? Yep, which is also called what? 3 pi halves. Yep. Okay, what's next? Oh, Briscovia beat you to it. Yep, 7 pi fourths. No, you're good. Briscovia, what's the last one? Yes, and why is that the last one? It simplifies down to what? What was it? Yeah, 2 pi. So we got 2 pi. And this was pi over here. So we are keeping 3 pi fourths, 5 pi fourths, and 7 pi fourths. That's what we're keeping. That's what's not on our unit circle yet. So 3 pi fourths. Oops, I keep doing that each time. Okay. 3 pi fourths is, okay, this is pi fourths, because that's 45 degrees. Where is 3 pi fourths? In between which two? Yep, in between 120 and 150. So that's 3 pi fourths. And how many degrees is that? Yeah, 135. Perfect. Okay, scooching down to quadrant 3. How many pi fourths would be up here? Yep, 5 pi fourths, which is how many degrees? Yeah, 225. Okay. Which one? This one? 5 pi fourths. Yep. Okay, Mark, last one to you. I'm over here. How many fourths am I at? Yeah, which is how many degrees? What's in between these two numbers? Yep, 315 degrees. Guys, you know the unit circle. Okay, you know part of the unit circle. You know the radians and degrees of the unit circle. If I scooch out, what else do we know about the unit circle? There are points, yes. What is the radius of the unit circle? What was it, Liam? It is r. What is r? Radius, yes, equals r. And the unit circle, unit, 1. It's always 1. This is a radius of 1. Okay, if this is a radius of 1, you already know 4 points on this diagram. Which 4 do you know? Okay, of the circle. So 0, 0 is the center. Yeah. So I guess you know 5 points. But on the circle, you know 4 more points. What 4 points do you know? Okay, where is 0, 1? Tell me when to stop. Yep, okay. Is this 0, 1? Yep, this is 1, 0. Okay. Tell me when to stop to find my next point. Okay, I'll tell you this again. What is this point? What is my radius? Yep, it's 0, 1. Because this is my x-axis, Piscovia, and this is my y-axis. So I'm going, in this case, I'm going over 0. I'm going up 1. So that's 0, 1.
Does that mean if we go on this side, would it be negative?
Yeah, negative in the x or the y.
What?
If I'm going negative in the x direction or in the y direction? Yeah, x. So negative 1, 0. Yep. Okay, down below. What would my last one be, Kyle? Wait.
Is this one?
Yep. 0, negative 1. Great. Now you know 4 points on the unit circle. Now there's some points in between. 0, 1. They are all fractions. So we're not, actually, we're getting away from radians for a second. So you don't have to worry about radians for a second. But you know what will help us? Don't we all love SOHCAHTOA?
That sounds familiar.
Yes. Yes. You gotta remember SOHCAHTOA. Oh. Okay, what is SOHCAHTOA? Who can spell it out for me? Yep, could have also seen it as SOHCAHTOA. Like this? Okay, either way is fine. This just helps you get your fractions. So this is sine of theta is opposite over what? Hypotenuse. Okay, what's C stand for? Cosine of theta is what? Hypotenuse. Yep, and what does T stand for? Yep, tangent if theta equals what? Opposite over adjacent. Ooh. Domain and range. Okay. Guess what? There are circles. There are a whole bunch of triangles inside of your unit circle, and that's how we're going to get all those points. So we were looking at 30, 60, and 45 degrees. Do you remember those degrees being anything special with triangles? What degrees were we focusing on a minute ago? Okay, I'll go back. Yes, 30. You can go back. 30. Yes, 45, 45, 90. We're going to look at that. And a 30, 60, 90. Yes, those two type of triangles. But let's start off with a basic triangle, because I think we need a refresher on SOHCAHTOA. Okay, draw a triangle. What type of triangle can I do SOHCAHTOA with? Yes, so you have a right triangle. Say gross to a right triangle? Yeah, that's fair. Okay. This angle right here is theta. Theta represents an angle. I'm going to call this A, B, and C. Do we also want to label our sides opposite, hypotenuse, and adjacent? Yes? Okay. Of theta, if I was a person standing here, if I'm looking at this wall straight across, this is my opposite. This is the opposite wall of the room. Okay? So I'm at opposite. I'm always standing on what side? Adjacent. Yep. If I'm standing on this, I'm right next to it. This is adjacent. This is refresher from geometry from last year. Should have done SOHCAHTOA for like a very long time. Well, okay, geometry people already know this. You've been doing it now. What is C? Yep, always my hypotenuse. If I'm opposite the 90 degrees, I am the hypotenuse. Opposite. Opposite. What was that? What did you say, Ronaldo? Yeah. Okay. Okay, we're gonna put this exact triangle on our unit circle. Okay, this is gonna be a very poor unit circle. But draw this on your paper, and then we'll add it to our actual physical unit circle. If you want to.
Wait, did we get to keep this?
Yeah. Ooh, that was bad. Okay, I have my very poorly drawn unit circle. I'm going to put my triangle right in this unit circle. The exact same one. Right there, 90 degrees. You can already label one of these sides with a length. Which one can you label with a length? This is my unit circle. Yes, I can label my hypotenuse. What is the length of my hypotenuse, Lily? 1. Yes, because the radius is 1 in the unit circle. Yep. Okay. We have 1 for one of our sides. At least we only have 3 minutes. That's my vision, so. Okay. This length down here. I'm on what axis right now? X. No, you're right. X. So let's call this x-axis. Or X. We're trying to find that side. Let's call that side X. Okay, this side. I'm going up what axis? Y. So let's call that Y. What? Because we're going up in a Y direction. So we're just going to call it Y. We don't know what Y is. Yeah? Angel, I'm confused. Okay. I want you to give me sine. If this is theta right here, this is my angle. Okay, this is my initial side, this is my terminal side. So we have theta. I want you to give me the sine, cosine, and tangent of theta. This is review from geometry. Sorry, I'm just going to change this. Okay, Kenny, I'm right here, right? Which side, okay, sine is opposite over hypotenuse, right? You know my hypotenuse. What is my hypotenuse? Okay, 1. Perfect, down there. What is the opposite side of theta? Y. Boom, you just found it. Now, what about cosine? Cosine is adjacent over hypotenuse, right? What's the hypotenuse? 1. Great. What's adjacent to it? X. Boom. Find tangent on your own. You got this. You know this. What is tangent of theta? Yep, y over x. So sine can simplify down to what? Y. What can cosine simplify down to? X. Boom. Right there is a coordinate. Our x is cosine of theta, and our y is sine of theta. So we can get that point. So this is our x and y coordinate. We're going to talk more about that tomorrow. But for now, you have homework.
What?
Oh my god. Homework 7.1, page 352. You're going to do 16 to 13. Oh, I wrote it up there. Then do 23. It's not that much. Sorry. Do it easy. 24, 36, 37, and 40. Do it easy. They're literally going to take you. Beatrice was in here and did all of it in like 12 minutes. So easy.
They already got this homework.
Yeah, they did it yesterday.
Are they in front of us?
No, well, you're in front of them now.
So does that mean